Hello everyone. In this video, we're going to be solving a rational equation. It's called a rational equation because we have rational expressions on the left-hand side, 1 over x and 1 over x plus 4. And the sum is equal to x plus 2. So I'll be presenting two methods, and we can start with the first one. So one of the things you need to be careful about if you're solving rational equations, of course that also goes for radicals, make sure this expression is not undefined. So we have to exclude x equals 0 and x equals negative 4. If we do that, we're going to be safe. Now, let's start with the first method, right? Because the first method is a little more painful, right? Okay, we're going to take the pain first, hopefully. So, yes, you can make a common denominator, but you can also do something equivalent, multiply both sides by x times x plus 4. It's kind of like a little easier. It's the same thing, but we don't have to worry about making a common denominator. If you multiply 1 by this, you get x times, okay, I gotta be careful here. When I multiply this by x times x plus 4, x is gonna cancel out, so I get x plus 4 in this one. Divide by 1. Make sense? And this one is gonna give me x because x plus 4 is gonna cancel out. So we get the following. And then, when you multiply the right-hand side, you're gonna have x plus 2 times x plus 4. All right, so that's going to give us a cubic equation. Let's see how we can solve it. Let's distribute all these things. That's not a multiplication symbol, by the way. I know it kind of looks weird, but if you write the x first, it's going to look better. So let's go ahead and do this. X multiplied by x plus 2 times x plus 4, which is x squared plus 6x plus 8. And the left-hand side, I'm kind of switching sides here to x plus 4. Great. Let's distribute. And then put everything on the same side and combine like terms. Bring negative 2x, you get 6x. Bring the negative 4 minus 4 equals 0. That's our cubic. And can we use the cubic formula? Absolutely. But I'm not going to use it, but I'm just going to tell you what you're supposed to do first. If you replace x with y minus 2 and choose your own variable if you don't like y. I don't know why people don't like y. Anyways, if you replace x with y minus 2, and 2 comes from 6 divided by 3, by the way, you're going to get rid of the x squared term, and you're going to get actually an expression without the quadratic, which is you're not going to have y squared. And then you can use Cardano's, Tartaglia's, whoever that guy is, right? Okay, great. So you can do that, and we used it in a previous video, but this time we're going to do something different. We can try RRT. What is RRT? Rational root theorem. So what is rational root theorem? We look at if the coefficient of x is 1, of course, we're looking at a monic here. Focus on the factors of negative 4. Plus minus 1, plus minus 2, plus minus 4. There aren't that many, right? It's not bad. Plus minus 1 is not going to work. I know that because remember, 1 and negative 1 works with the sum of coefficients, like evens and odds and all of them. So obviously that's not going to work. You can quickly check. So one of these should work. And without further ado, let me tell you, x equals negative 2 works. And obviously, it's also kind of clear that positive values are not going to work, right? Because if you kind of write your equation this way, look at that. It's kind of interesting. 2 is going to make this one too large, right? It's not going to equal 4. And 4 is going to make it even large. So the answer must be negative, and negative 2 works. Okay, great. So how do we go from here? Since we know x equals negative 2 works, factor theorem tells us that x plus 2 is a factor. So we can kind of divide by x plus 2, polynomial, long division, whatever. But here's my original equation. And that is not actually the original. My original equation was x cubed plus 6x squared plus 6x minus 4 equals 0. Now I'm going to arrange the terms. X cubed plus 2x squared. And you can do this, it's not too hard. And then plus 4x squared to get 6x squared. Now I need to add 8x to make this divisible by x plus 2. And then I have to subtract 2x to make up for this. And then I have to subtract the minus 4, that's the last term. And we're done. And now we're going to take out x squared times x plus 2, 4x times x plus 2, minus 2 times x plus 2. The rest is fairly easy, and we're going to take out an x plus 2 because we already knew that. That was a factor, but this helps us find the other factor. If you like long division or synthetic division, you can do that as well. So from here, it's obvious that x equals -2, one of the solutions. This one is going to give us irrational solutions, right? We can go ahead and do the following. Add 2 to both sides, so put the constant on the right-hand side, and complete the square. How do you complete the square? Look at this coefficient. What is half of 4 squared, right? That's something you should normally learn, like maybe 9th or 10th grade in algebra. So it's 4. Add 4 to both sides, and that makes the left-hand side a perfect square, and that's perfect. So this is like x plus 2 quantity squared equals 6. Square root both sides, and there are two numbers whose square equals 6. You should know that. X plus 2 can be root 6, or x plus 2 can be negative root 6. And from here we get the solutions, -2 plus root 6, because I like to write the rational part first. -2 minus root 6 is another solution, along with x equals -2. We have 3 solutions because this is a cubic, right? And they're all real, for reals. Okay, great. So this equation has 3 real solutions, and at the end, I'm going to show you a graph, which is kind of interesting, sort of. A rational function intersecting a linear function, which is a straight line. Anyways, let's go ahead and talk about the second method. All right? So hopefully this made sense. Let me quickly summarize what we did. We kind of, simplified this, and then we found a possible solution with rational root theorem, and then we discovered that x plus 2 is a factor. We divided by that, or arranged the factors, and we got a quadratic which can easily be solved. The cubic formula is not that nice. And quintic, it doesn't exist. Quartic, forget about it. It's way too complicated. Too long. It doesn't even fit on a screen. So, second method is about what? Shortness. Okay, it's pretty short. So first of all, I want you to note that x plus 4, remember we had x and x plus 4 at the bottoms, divided by 2 is x plus 2. That's interesting. So we have averages here. Yay, that's cool. So here's what we're going to do. Oh, let me rewrite the original problem. I know it's gone. So here's what I'm talking about, right? You average these two things and you get x plus 2. So that's nice. This is a special equation. So I'm going to do the following. I'm going to name x plus 2 something. How about z? Okay? And if you do that, x is going to be replaced with z minus 2, and so on and so forth. You can figure out the rest, right? So that gives us the following. 1 over z minus 2 plus 1 over z plus 2 equals z. Remember, this is z, right? All right, great. To z or not to z. Then make a common denominator if you want. Z plus 2 here and z minus 2 here. And at the bottom, from difference of 2 squares, we get z squared minus 4. And we get z. So the bottom expressions are conjugates, sort of. So they differ by sign. That's a pretty good thing. First of all, the 2 and the -2 cancels out. And 2 plus, that looks like it. Okay, my z2 looks like a 2, I agree. But that's how I make my z's. Okay, so z plus z is 2z, or not 2z. I'm going to tease you with that a little bit, just a little bit. Z cubed minus 4z. Okay, so let's put the 2z on the right-hand side and then write our equation like this. Make sense? And now this is very easily solved because you can take out z. And then from here we get the following. Z equals 0, z equals root 6, and z equals negative root 6. But remember, z is x plus 2, or x is z minus 2. So from here, x is going to become -2. From here, x is going to become root 6 minus 2, or you can write it as -2 plus root 6. And this is going to become x equals -2 minus root 6. So those are going to be all the solutions like before. And here's the graph. All right, here's our graph. Yay. So we have a rational function that has some asymptotes, kind of curves, in an interesting way, some type of symmetry, whatever, blah, blah, blah. But these two intersect at 3 points. One of them is -2, 0. The other ones you already know. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.